Good afternoon students. Today we are going to discuss Digital Signal Processing Laboratory 17 EEL 68 by Professor D.A. Vanilla and Ramya K. Experiment number is 5. Computation of endpoint DFT and to plot the magnitude and phase spectrum. Aim of the experiment is to compute and plot the magnitude and phase spectrum endpoint DFT using simulation software MATLAB. Now this is the program which I have typed already. If you want to type the program, you have to go to this new window. If you click, you will get new window, and normally you can type the program. After typing the program, you should give the run button. Now here n is nothing but your number of samples that I have to give. So now that is in the sequence, how many samples are there, that should be you have to enter for n value. So now n is nothing but integer which is varies from 0 to n minus 1, and k also integer which is varies from 0 to n minus 1. This omega n is nothing but twiddle factor or phase factor, that is e power minus j 2 pi by n. Now nk is nothing but your integers that both you are going to multiply. First you are going to take k as a constant, that k is equal to 0 and n values varies from 0 to n minus 1. Now twiddle factor is omega n to the power nk. So this omega n, you are going to find the twiddle factor value for suppose if you use n equal to 4 for 4-point DFT, you are going to make the matrix and the n value and k value you are going to substitute. For first k is equal to 0, n varies from 0 to n minus 1, and for k equal to 1, n varies from 0 to n minus 1. And we are going to display the DFT of the sequence xk, that is x of k. If you apply this x is nothing but your continuous time domain signal. If you apply DFT, then you will get x of k, and for that you are going to find the magnitude, and magnitude is nothing but magx is nothing but absolute of xk, that is modulus of xk. Next phase, you are going to find phase x is equal to angle of xk into 180 divided by pi. Now I am going to name the entire magnitude response and phase response as figure 1. If you want to give, you can give, otherwise you can give some other name, nothing wrong in that. Now subplot is the entire screen will be splitted into two, that is two rows, and the first one you are going to plot in the first place. Okay, in the first column, in the first row, you are going to place only one diagram, that is magnitude response, that plot k comma magnitude x. Now title I have given magnitude response curve, and y label is magnitude, x label is time. Next you are going to make the subplot 2, that is the entire screen already it is divided into 2. So 2 means 2 rows will be there, and you are going to plot the only one plot, that is phase response plot, that you are going to place in the second row. So next you are going to give plot k comma phase x. Title will be phase response k, y label, x label. Now I am going to simulate the program. So use this run button. You run this button, then I am going to command window. So now I will give the n value as 4. Next I am going to give next enter. So see, now I got the magnitude response curve and phase response curve for my input given x is equal to 1, 2, 3, 4, and the number of points is 4. Okay, thank you students. Now what are the data? The same data you have to enter, it is not a thing. Here you can enter 4, 6, 8, n number of data you can enter, and you can find the output sequence. Okay, so xk is nothing but your DFT of your x of n, where x of n is nothing but 1, 2, 3, 4. If you apply DFT, you will get your x of k is equal to 10. You will first value will be only real value, and the second one you will have real value as well as the imaginary value, and third also real and imaginary, and fourth also real and imaginary. So for that, if you take the magnitude response, so magnitude, you know the formula for taking magnitude of the x of k is nothing but square root of a square plus b square. For x of k, for the first value only 10, so the imaginary value is not there, so you are taking a square root of a square is 10 square plus b square is 0, square get cancelled means you will get only 10. The second minus 2 plus 2j, for that if you take magnitude means square root of a square plus b square, that is a square is nothing but 2 plus b square is nothing but 2, 2 plus 2 4, square root of 4, you will get this value. So like that you have to do, and base response, that is nothing but tan inverse of b by a. B value, first one b is nothing but 0 and a value is 10, so like that all the values you have to calculate. Next, this is the obtained output I have shown here. Practically I have shown, this is the theoretical value, whatever the values I am given, same thing I have got. So the result, that's the computation of n-point DFT and the magnitude response and phase response is simulated using MATLAB and output is verified.